Okay, this is the third lesson in the week of April 27th through May 1st. And it's one more thing to think about when we deal with solutions, and that is a technique called dilution. Now, I've included this because it's relatively simple, but it also helps you to think through the parts of a solution. What we're going to be dealing with here is diluting a solution. And you say, well, why would I want to do that? Well, in the chemistry lab, for instance, when I buy hydrochloric acid comes as a 12 molar solution. Sulfuric acid, H2SO4, comes as an 18 molar solution. There's nitric acid comes, I believe, as 15 molar. In other words, it comes to you concentrated, but I don't want it that concentrated. When I would work with you in class, we would never work with 12 molar hydrochloric acid. It's just too dangerous. The more concentrated it is, the more likely there's going to be to have somebody get burned by it or something else. And so what we often do is cut it down. In fact, we'll say, well, I need X number of moles, and so we'll use a smaller amount, but we'll add water to it so that it is, we're able to do our reaction. So what I'm going to show you today is called the dilution equation. So imagine I have a glass here and I put some food coloring in it. This isn't a real solution. I'm just going to be honest with you. But let's say that this was very concentrated and I wanted to dilute it. Well, how am I going to dilute it? Well, I obviously need to put a little bit into something else, and then I have to add some water to that. And I now have a very dilute solution, all right? We never go the opposite direction. You never concentrate a solution. We always dilute a solution. So let's take an example. Let's say that I had like I said, I have 12 molar hydrochloric acid solution. This is what comes out of what we would call my stock bottle. Or sometimes this will be known as that's what comes out of the stock bottle. And I want something different. In fact, most of the time with you guys, I want, say, let's just throw out a real simple one here, 2 molar. HCl. I will always work between 1 and 2 molar hydrochloric acid. And let's say for our class, every lab group needs 50 milliliters, and there's 18 lab groups. So 50, 500, 900. Let's say we need 900 milliliters. So I have 2 molar HCl, and I want 900 milliliters of that. Well, the question is, how much of this should I pour out, and how much water should I add to it? Well, the interesting thing is if you look at this, knowing molarity and milliliters, I can get to the number of moles. And so 2 molar times 0.9 liters, I need 1.8 moles. Over here, if I work backwards, I would say, well, I need 1.8 moles of 12 molar. And that means I need, remember, molarity times liters is, well, let's back it up. Molarity is moles divided by liters. So molarity divided by moles is equal to the liters. So I have 1.8, I have 12 molar divided by 1.8 moles. And what I need is 12 divided by 1.8. I need 6.6. Now something's not right here. Molarity is moles divided by liters. Oh, I got it backwards. I'm sorry. Molarity is moles divided by liters, so molarity times liters is moles. So liters is moles over molarity, and I have 1.8 moles divided by 12 molar, and 1.8 divided by 12 is 0.15. So basically 0.15 liters of solution is what I need. So here's what's going to happen. I'm going to take and I'm going to pour out 0.15 liters of 12 molar HCl. And then I'm going to add to that enough water to get to 0.9 liters. And I'm going to add that much solution. So I'm actually going to add 0.75 liters of water. Okay? Now, some of you may be a little bit scared because you might be saying, whoa. I have to reason all that through. Actually, you don't. And the reason is there's an equation that works for this. And that is that if you take M1L1, molarity times liters, that has to equal M2L2. In other words, let me come back to this. Just a second. Let's say that I said I want this to be filled and I want to know how many moles there are. I can figure out how many moles to pour in there. And this is the right number of moles. By adding this, I did not change, listen carefully, I did not change the number of moles. The number of moles is however many of the green food coloring particles are in there. We're counting those. That didn't change. This would be like having a room filled with, say, people who are with red shirts. And I've got a big bunch of those together. And then I add the room with a whole bunch of people who don't have red shirts. The number of people in red shirts remains the same. That count doesn't change just because I've added more stuff to it. So basically, the dilution equation, and this is it right here, the dilution equation, molarity times liters is equal to the second molarity times the second liters. Now watch. If I take and put in here 12 molar times however many liters, and here I wanted 2 molar times 0.9 liters. And if I divide through both sides by 12 molar, the number of liters that I want to pour out of my concentrated solution is this. And guess what? This is going to work out to be 0.15 liters. Right? So let me just check. 12 times 2 times 0.9. 1.8 divided by 12, yeah, 0.15 liters. Now, if I was to just ask the question, how many liters of 12 molar HCl are needed to have 2 molar 0.9 liters of 2 molar solution. Well, then the right answer is 0.15. But if I was to ask the question, how much water do I need to add? So the question very well could be, how much water should be added to 12 molar hydrochloric acid to have 2 or 0.9 liters of a 2 molar solution. Okay, well, in order to do that problem, I do have to figure this out, and I have to say, well, it's 0.15 liters plus whatever to get to 0.9 liters, and that would be that 0.75. Right. So, the dilution equation is actually fairly simple. Now, there's something that I should point out, and that is, if the whole problem is in milliliters, you actually don't need to change this. In other words, the actual equation, and the reason I use it this way is that hopefully you can see that this is the moles of number 1 is equal to the moles of number 2. But the actual dilution equation looks like this. It's M1 V1 is equal to M2 V2. So they're always going to give you the more concentrated molarity and then figure those out. Every once in a while they might turn it around and say, well, we diluted it by adding this, what was the molarity? But that's not real common. So let's try one. Let's say that you want 20 milliliters of a 1.4 molar solution, let's say H2SO4 solution. How many milliliters of 18 molar H2SO4 solution do you need? Well, the nice thing is, because it's in volume, as long as the volume is, as long as this side is milliliters, this will be milliliters. So we're going to do M1, I'm going to use the larger one, 18 molar, times L1 is equal to 1.4 molar times 20 milliliters. Divide by 1.8 molar, not 1.8, 18 molar. Notice what happens. L or V, I put V here, it should have been V1. V1 then is, so 1.4 times 20 divided by 18, and I need 1.6 milliliter. Okay, so once again, I'm just going to finish this up. If I wanted to make this solution, what I would do is I would take a graduated cylinder, I would put in 1.6 molar, 1.6 milliliters of the sulfuric acid, and then I would add water to get to 20 milliliters. And so really what I would need to add to it would be 18.4 milliliters. So there will be some questions where they say how many milliliters do you have to add, and that just involves thinking it through at that level. How much do I have? How much do I want? Subtract it and you'll get to the answer. So, all right. There's one more lesson in this section that leads us into the last chapter that we'll end up doing, which is acids and bases, but we'll get to that on the next video.